Hello guys, so today we will just go through this lab session working with JSON, arrays and structs in BigQuery. In my previous videos I have posted, let me just show you. Yeah, in my previous YouTube videos I have posted the lab sessions of these entire categories, so please check it out guys. And now I'm just working, I mean, on today in this video we'll just go through this lab session working with JSON arrays and structs in BigQuery. Let's go through overview. BigQuery is Google's fully managed, no ops, low cost analytics database. With BigQuery, you can query terabytes and terabytes of data without having any infrastructure to manage or needing a database administrator. BigQuery uses SQL and can take advantage of pay as you go model. BigQuery allows you to focus on analyzing data to find meaningful insights. In this lab, you will work in depth with semi-structured data, ingesting JSON, array data types inside of BigQuery, denormalizing your schema into single table with nested and repeated fields can yield performance improvements. But the SQL syntax for working with array data can be tricky. You will practice loading, querying, troubleshooting, and unnesting various semi-structured datasets. Okay, so this is a setup and requirement, guys. This is nothing but just clicking on this lab, start lab button, and we will get all the credentials. I will just open this Google Cloud in incognito window. Username would be populated here, and password we can just copy and paste it. And now it will open up new Google Cloud Console with these credentials. Yep, agree and continue. So this is what they have mentioned in setup and requirements. That's it. And this is ready to open the BigQuery console. In the Google Cloud Console, select navigation menu, BigQuery. Yeah. So this part is for like access and BigQuery. As you can see in the navigation panel, there is BigQuery service. You can also search it in the search bar. If you type BigQuery, yep, it will open up BigQuery console. Content, yep. Now what do we have to do? Let's see. Create a new dataset to store the tables. In your BigQuery, click the three dots next to your Quick Labs product ID and select create dataset. Name the new dataset fruit underscore store. Okay, let's copy this. Leave the other options at their default values, data location and default expression, and click on create dataset. Okay, let's do that. Create dataset. Here's the dataset ID. Click on create dataset. Done. So dataset, let's check that. Yep, fruit underscore store dataset has been created. Practice working with arrays in SQL. So normally in SQL you will have a single value for each row like this. List of fruits below. Okay, row 1 raspberry, row 2, row 3, row 4. What if you wanted a list of fruit items for each person at the store? It could look something like this for each person. Okay, in a traditional relational database SQL, you would look at the repetition of names and immediately think to split the above table into two separate tables, fruit items and people. That process is called normalization, going from one table to many. This is a common approach for transactional databases like MySQL. For data warehousing, data analysts often go the reverse direction, denormalization, and bring many separate tables into one large reporting table. What are some potential issues if you stored all the data in one giant table? The table row size could be too large for traditional reporting databases. Yep, true. Any changes to a value like customer email could impact many other rows like all their orders. Data at different levels of granularity could lead to reporting issues because like less granular fields would be repeated. Yes, all of the above. Yep. So now you are going to learn a different approach that stores data at different levels of granularity all in one table using a repeated fields. Okay, so instead of having the same name for different records, here we have only one. So what looks strange about the previous table? It's only two rows. Okay, so there are multiple field values for fruit in a single row. The people are associated with all of those field values. Interesting. Oh, what's the key inside the array data type? An easier way to interpret the fruit array. Okay, so everything is in a single array. Yep. So both of these tables are exactly the same. There are two key learnings here. An array is simply a list of items in a bracket. Yep. BigQuery visually displays arrays as flattened. It simply lists the value in the array vertically. Note that all of those values still belong to a single row. Try it yourself. Enter the following in the BigQuery query editor. Let's check this. Okay, let's run it. Yep. Okay, this is an array. Okay, I mean we are putting these four values as fruit array. Okay, click on run. Yep. Now try executing this. Let's check this as well. Have included number. Okay, array elements of types integer 64 does not have common super type. So you should get an error that looks the following. Yep. Why did you get this error? Data in an array cannot exceed four elements. I don't think so. Data in an array must all be of the same type. Data in an array must only be strings. Yeah. The second one, yeah, array should have similar data types. Yeah. Arrays can only share one data type, all strings, all numbers. Here's a final table to query against. Let's run this. Okay. Now click run. Okay. Oh yeah, we have done this. After viewing the results, click the JSON tab. Superb. Okay. Loading semi-structured JSON into BigQuery. What if you had a JSON file that you needed to ingest into BigQuery? Create a new table in the dataset. Click on a fruit dataset store and click on the OK. Open. Now you will be able to create table option. Name the table fruit details. Add the following for the table. Okay, let's click on this and create table. And the table name. Yep. Let's check. Source. Choose the Google Cloud Storage in the create table from dropdown. Okay. Google Cloud Storage. Cool. Select the file from a cloud storage bucket. Selecting. Okay. File format JSON L new line delimited. Okay. Yep. It is automatically updated. Call the new table fruits underscore details. Yep. Check the checkbox of schema auto detect. Okay. So in the okay, click create table. In the schema, note the footer is marked as repeated, which means it's an array. Okay, let's check that. So create table. Okay, fruit details has been created, and fruit underscore array field is repeated, which means it's an array. Interesting. So recap: BigQuery natively supports arrays. Array values must share a data type. Arrays are called repeated fields in BigQuery. Let's check our progress. This is done. Now creating your own arrays with array underscore agg aggregate function, I guess. Don't have arrays in your table already, you can create them. Copy and paste the below query to explore this public dataset. Let's copy this query. Let's do, yeah. Click on run. Okay, job information. Let's see. Click run and view the results. How many rows are returned? I can see 111. Yep. Now use the array aggregate function to aggregate our string values into an array. Copy and paste the below query to explore this public dataset. Let's do this. Click on run. Let's check how many rows are. Yeah, I can see only two rows, row 1 and row 2. Yep. How many rows are written? 2. Yep. Next, use the array underscore length function to count the number of pages and products that were viewed. So I think they are focusing on this also. This is other data set, I guess. Let's see what data set. It's the same thing. Okay. Let's do this. So we are not going in detail into this SQL queries, guys. I'm just trying to do whatever the task that has been posted up here in order to complete this lab. In the future videos, I might try to put them all the arrays, I mean SQL queries, and I will try to explain them. And also I will learn, I mean, I might don't know everything regarding this BigQuery SQL queries as well. So I have to dig deeper. Yep. Let's check this query. Results, okay, number of pages 100, 111, 109, 2. So how many pages were visited by this user on 2017-0801? Let's check. Yeah, 109. Interesting. Next, deduplicate the pages and products so that you can see how many unique products were viewed by adding distinct to array aggregate. Let's copy this query, paste that down here, click on run. Let's check. Let's check the question. How many distinct pages were visited by this user on 2017 August 1st? Distinct page, yeah, 61. But I don't see any other option. Oh, sorry, let me check. Is this the one? Distinct products. Oh, I think this is a distinct pages, right? Yeah, 8. Click check my, yeah. Check out progress. So this is a recap. Can do some pretty useful things with arrays like finding the number of elements, array underscore length, which we have used in our previous queries, and deduplicating elements with array aggregate. This is also we have done deduplicating, and what else, ordering elements using order by, yep, limiting array aggregate field by limit by, yep. Now querying datasets that already have arrays. The BigQuery public dataset for Google Analytics BigQuery public dataset dot Google underscore analytics dot sample has many more fields and rows than our course dataset. More importantly, it already stores field values like products, pages, and transactions natively as arrays. Copy and paste the below query to explore the available data and see if you can find fields with repeated values. Let's check this guy. See what does it return. Results, okay. How many rows? Let's check. Can see only row 1. Scroll right in the results until you see the hits.product.v2 product name field. Multiple field aliases are discussed shortly. Let's check this field. I'll just copy this and try to find it using, sorry, let me, yep. Yes. Sorry. It's not product or v2 dot product name. Yep, this is the one. You will note a lot of seemingly blank values in the result as you scroll. Why do you think that is? The fields that appear to be missing data are actually at a higher level of granularity than other fields. The dataset is missing data values for those fields. BigQuery is still loading the data for those fields. I guess this is the one. Yep. The amount of fields available in the Google Analytics schema can be overwhelming for analysis. Try to query just the visit and page name fields like before. Let's do this, guys. Cannot access. Okay, let's check. Yeah, you will get an error. Yep, we got this error. Before you can query repeated fields arrays normally, you must first break the arrays back into rows. For example, the array for hits.page title is stored currently as a single row, like, and it needs to be okay. How do you do that in SQL? Use the unnest function on your array field. Unnest. Okay, this is the keyword. Let's do that. We are doing unnesting. Okay. Okay. Interesting. We will cover unnest more in detail later, but for now, just know that you need to unnest arrays to bring the array elements back to rows. Unnest always follows the table name in your from clause. Think of it conceptually like pre-join table. Okay, let's check our progress. Yep, this is done. Now, yeah, introduction to structs. You may have wondered why the field alias heat.page looks like three fields in one separated by period. In one, okay, page title. Yeah, it is separated by, yep. Just as array values give you the flexibility to go deep into the granularity of your fields, another data type allows you to go wide in your schema by grouping related fields together. That SQL data type is the struct data type. The easiest way to think about a struct is to consider it conceptually like a separate table that is already pre-joined into your main table. A struct can have one or more many fields in it, the same or different data types for each field, its own alias. Sounds just like table, right? Yep. Explore a dataset with structs. To open the BigQuery public dataset, click Add Data, pin a project, enter project name, and then write BigQuery public data name and click on pin. Okay, let's copy this, guys. So here, add data, pin a project, enter project name. Yep. Yes, I think we got the public dataset. Open BigQuery public data, find and open Google Analytics sample. Google Analytics sample, let's check. Yep, I've selected that. Click the GA sessions table. Okay, selected that as well. Start scrolling through the schema and answer the following question by using the find feature of your browser. In a BigQuery, wait just a moment, guys. In a BigQuery schema, a struct field is noted as a record type. Search for record in the Google Analytics schema and how many structs are present in this data set. Okay. So basically, we have to search for the fields which are having the record. I mean, record. So I can see there are six, only six here. Okay, how many? Oh, okay, got it. I have to check here as well. Six are done. Seven. Okay, I'll just open all of them and I will use the find feature. Okay, it's really, so it's I think stuck inside a struct, I guess. Okay. Oh, it's really long. Okay, I think hope. Okay, let's again. Only eight or I can't see it. Okay, this this feature is I think it's not that great, guys. Let's check this. One, two, three, four, five, six, seven, eight, nine, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it's more than 20. Yeah, so then it would be that two. Yeah. What are the names of some of the struct fields? Struct record type fields. Okay. Okay, let's check. Cancel. Yep. Device, geo network, custom hits. So totals, traffic. So totals, traffic source dot add click info. That is also record device. All the yep. So how can both traffic source and traffic source dot add words click info both be structs? A struct can have another struct as one of its field. You can nest structs. Yes, I guess this is the one. In a BigQuery schema, an array field is noted as repeated mode. Search for repeated in the Google Analytics schema. How many arrays are presented in this dataset? So we have to check for repeated. Okay. Let's check the schema. Can we check? Yes. No. I'm just checking here. Close it. Okay, I have to go through individually. Repeated, I can see only two here. Let's check this. Two. Can see only two. Oh, oh, two, three, four, three, four, five, six, seven, seven, eight. I'm Not sure. I'm just guessing. I see. Yeah, 11. As you can imagine, there is an incredible amount of website session data stored for a modern e-commerce website. The main ad- the main advantage of having 32 structs in a single table is it allows you to run queries like this one without having to do any joins. Okay, let's do this, guys. Okay, instead of using joins, you can just use this. Okay. Note the asterisk syntax tells BigQuery to return all the fields for that struct, much like it would if totals dot asterisk was a separate table we joined against. Storing your large reporting tables as structs, pre-joined tables, and arrays a deep granularity allows you to gain significant performance advantages by avoiding 32 table joins. Get granular data from arrays when you need it, but not be punished if you don't. Yeah, BigQuery stores each column individually on disk. Have all the business context in one table as opposed to worrying about join keys and which tables have the data you need. Okay. Practice with structs and arrays. The next dataset will be lap times of runners around the track. Each lap will be called a split. With this query, try out this struct syntax and note the different field types within the struct container. Just copy this and run this query. Yep, Rudish. Yep. So runner.name, runner.split. Okay, let's check this, guys. So what do you notice about field aliases? Since there are fields nested within the struct, name and split are a subset of runner, you end up with a dot notation. What if a runner has multiple split times for a single race, like time per lap? How could you have multiple split times within single record? Hint: the splits all have the same numeric data type. I guess we can use array. Yeah, in an array, yes. Yep. With an array, of course, run the below query to confirm. Okay, let's run this. Yes. To yeah, to recap, structs are containers that can have multiple field names and data types nested inside. Arrays can be one of the field types instead of struct as shown above with splits field. Now, practice ingesting JSON data. Create a new dataset titled racing and create a new table titled race underscore results. Click on racing dataset and click create table. Okay, let's create a dataset with racing. Okay, let me minimize this. Okay, here I have to create dataset. This is a dataset ID. Create dataset. So dataset has been created. Now here I have to click on this and create table. And while creating table, select a Google Cloud Storage under create table from drop down. Okay. Then this is the data source. Okay, select file. Okay, the file format is also automatically updated. And in schema, click on edit as text slider and add the following. Okay, edit as text. Yep, this is done. Create table. What's the table name? Yeah, race results. Okay, now create table. Now, yep. After the load job is successful, preview the schema for the newly created table. Okay, let's do this. Go to table, schema. This is yep. Which field is the struct and how do you know? Whatever record that is a struct and repeated is array. The participant field is a struct because it is of the type record. Yep. Which field is array? The participants dot split field is an array of floats inside of the parent participant struct. It has a repeated mode which indicates an array. Values of that array are called nested values since they are multiple values inside of a single field. Check my progress. Let's do this, guys. Yeah, yeah, this is done. Now practice querying nested and repeated fields. Let's see all our races for our 800-meter race. Yep. Okay, 800-meter race. Okay. How many rows were returned? Yep, answer is 1. Yep, I can see only row 1. Yes. What if you wanted to list the name of each runner and type of race? Run the below schema and see what happens. You cannot access the field name. Okay. Error, yes. Much like forgetting to group by when you use aggregate functions. Here there are two different levels of granularity. One row for the race and three rows for the participant names. So how do you change this to this? Okay. In traditional relational SQL, if you had a races table and a participant table, what would you do to get information from both tables? You would join them together. Here the participant struct which is conceptually very similar to a table is already a part of your races table, but is not yet correlated correctly with your non-struct field race. Can you think of what two-word SQL command you would use to correlate the 800-meter race with each of the races in first step? Yep, cross join. Yeah, because one specific row record in the left table would be interrelated to other table, right? So the cross join. Yeah, let's do this. Click on run. Table participants must be qualified with the data set. Let's see, why did we get? Yeah, I got the same error. So even though the participant structure is like a table, it is technically a field in the racing. Okay, add the dataset name to the query. Race results. Okay, interesting. Click run. Yep. Listed all the races for each race. So we can simplify the last query by adding an alias for the original table, replacing the words cross join with a comma. A comma implicitly cross joins. This will give you the same query result. Okay, yes. Selecting race participant name. Got the same result. Yep. If you have more than one race type, 800, 100, 200, wouldn't a cross join just associate every racer name with every possible race like a Cartesian product? No. This is a correlated cross join which only unpacks the elements associated with a single row. Okay. Recap of structs. A SQL struct is simply a container of other data fields which can be of different data types. The word struct means data structure. Recall the example from earlier. Yep. Structs are given an alias like a runner above and can conceptually be thought of as a table inside of your main table. Structs and arrays must be unpacked before you can operate over their elements. Wrap and unnest around the name of the struct itself or the struct field that is an array in order to unpack and flatten it. Okay. Lab question. Answer the below questions using the racing dot results table you created previously. Write a query to count how many races were there in total. Okay, let's do this thing. Let's count. Okay, sorry, this is a partial return results. Oh, query. Oh, okay. Remember, you will need to cross down in your struct name as an additional data source from. Okay. Okay. Let's do the see the solution itself. I will spend more time on other. I mean, I mean, getting into deeper with these queries in other videos, guys. Yeah. Right now, I'm just trying to see what's happening. Yep. Erases. Yep. Check my progress. This is done. Lab question. Okay. Unpacking arrays with Honest. Write a query that will list the total race time for races whose names begin with R. Order the results with the fastest total time first. Use the Honest operator and start with the partially written query below. Complete the query. Okay. Hint, you will need to unpack both the struct and array with the struct data source. Okay. Okay. Be sure to use aliases where appropriate. Okay. Yep. Yeah. Group by. I have to do. What is? Write a query that will list total race time for races whose names begins with R. Order the results with the fastest total time first. Use the unless operator and start with partially written query below. Unless operator. Okay. Let's do group by. This is the participant name, and order by we have to do as mentioned total ascending or descending. Fastest. So fastest. So descending. Wait. Or am I missing anything? Okay, in where clause I haven't. Okay, where name starts with begins with R, right? So p dot name. I think I have to use like star R. There's no data to display. I think I'm missing something, guys. Okay. Why are you ascending? Okay, ascending. Oh shit, sorry. Like L. Let's do this. Something like. Oh, starts with R. I have. Yep. Yep. I think I have to learn deeper. I mean, understand the SQL queries. I think this is done. That will list the total time for arrays whose names begin with R. Ascending, yes, this is we have done it. Does this group by where p dot name like yes. Oh, we haven't unnested these field values. Oh, sorry, unnest. Okay, let's rerun this. I got the same output. I don't know what's the problem. Yeah. Yep. Filtering within array values. You happen to see that the fastest lap time recorded for the 800 meter race was 23.2 seconds, but you did not see which runner ran that particular lap. Create a query that returns that result. see. Click on where split time is. What did he say? 2.32, right? Let's do it. 2.32. Oh, sorry. Let's. I guess it should be in strings. No. I damn right. 2 point. Yeah. Oh, wait. It has to work. Wait. Oh, yeah. Syntax is not good. Yeah, I got this thing. But I haven't unnested the values. Let's check. Yep, I haven't unnested. Okay, let's check the progress. Then, okay, guys, it's been a long lab. So I think I have to dig deeper into this SQL queries, like using in order to better understand unnest and everything. Now I will just go through. See why it is still. Yep, this is also done. So I will just go through the brief overview, like what we have done in this lab. It's pretty long. Yep. So we've just gone through the BigQuery overview. This is the setup, and we have just created a data set to store the tables. Then we have done some, I mean, practice working with arrays in SQL, some background on arrays, then some few more questions, and loading this semi-structured JSON file into BigQuery. Then we have created our own arrays using array aggregate function. Then few more questions on that. Then querying datasets that have already arrays. Then that also we have done it. Then we got some introduction to structs. Then how do we identify the structs, everything, and also practicing structs with arrays together. And also we have ingested some JSON data, and we have used this file for a schema instead of auto detecting the schema. Then we have practiced querying nested and repeated fields. So nested in the sense struct and repeated fields is like arrays. That's, I think that's it. And lab question on struct. Then unpacking arrays using unnest feature, because while querying the data we have to unnest and everything. Then filtering within array values. That's it, guys. Yep, thanks for watching, guys, and let's end this lab and let's check what this is pending on the data engineering track. Let's see for the specific build and optimize. So yep, this is done, and we have two more. I will just upload this one as well. Yep, thanks, guys.